Okay, in section 2.5, we're going to look at some more properties of functions, starting with increasing and decreasing. Where's a function increasing and decreasing? Okay, f is called an increasing function on the interval a to b if x1 less than x2 implies that f of x1 is less than f of x2. Okay, so what does that look like graphically? I mean, you already have an idea of what increasing and decreasing might look like, but if we have a function, and let's say it does something like this, and we've got x1 over here and x2 over here. So clearly x1 is less than x2. Okay, and we can see what f of x1, which is right here, is less than f of x2. Okay, and so we say that the function is increasing, and we can see that on this interval as we move from left to right, we have an increasing function. Okay, on that interval. All right, we say the function is decreasing on the interval from a to b if x1 less than x2 implies f of x1 is greater than f of x2. Okay, so same kind of situation, except this time we're going to end up with a function that's decreasing. So let's say we have something like that. Okay, we can let x1 be over here again, and x2, doesn't matter, right here. Okay, we can see f of x1 is greater than f of x2, and so we call this a decreasing function on the interval. Okay, and you don't have to worry so much about the pictures, but what you do want to understand is, you know, what increasing looks like, what decreasing looks like, and finally what a constant function looks like. Okay, f is called a constant function on a to b if x1 less than x2 implies, yes, I think f of x1 equals f of x2. Okay, for every value in the interval. Okay, but a constant function looks like everybody in the interval gets the same value. All right, that's our constant function. Okay. So we want to look at this illustration and determine the intervals over which the function is increasing, decreasing, or constant. So when I look at this one, and usually I'll say this before we answer it, when we do this, we describe the intervals using the x values. Okay, so let's just start on the left side here. What's going on here? It's decreasing. So what's this interval where it's decreasing? Okay, negative infinity to negative 1. Very good. So that's where it's decreasing, negative infinity to negative 1. Okay, then what happens? Okay, it's constant from negative 1 to 4. And then finally, what happens? Not negative infinity, but positive infinity, right? From 4 to infinity, it's decreasing. Okay, and I know it continues to go on because of the arrow at the end of the line. Okay, Questions about that? I don't mind. No, 4 to, oh yes, they are both decreasing. I'm sorry, I put it on increasing. Let me move that. Very good. Oh, because we read it from left to right. So we want to be consistent in that. So when we look at this from left to right, it's doing what? Decreasing. Okay, other questions? Okay, very good. All right, we want to talk a little bit about relative max and min. All right, it says let A be in the domain of a function f. We say that the value f of A is a relative maximum of f if there's an interval x1 to x2 containing A such that f of A is greater than f of x for every x in the interval x1 to x2. Okay, so if it's the largest value in the interval, the function value in the interval, we say it's a relative max. Okay, we say that it's a relative min if there's an interval containing A such that f of A is less than f of x for every x in the interval. Okay. The value f of A is called an extreme value of f if it's either a relative max or min. Okay. If I want you to find both of them, I'll say find all extreme values. Something else that we should make a note of, conscious note of, is the extreme value or the max or the min is actually f of A, not A. So we say that it occurs at A, but the value of the function at that point, that's what's the max or the min. Does everybody understand the distinction I'm trying to make there? Okay, we can find out that the maximum occurs at x equals 2, but if we want to know what the maximum value actually is, we have to take 2 and plug it into the function. Okay? Alright, y'all are really quiet. Okay. Alright, a turning point is the point where the graph changes directions from increasing to decreasing or decreasing to increasing. Okay, let's see if we can locate in this example some relative max and min. All right, let's start with relative max. Do you see any? What is it? 1, 2. Okay. All right, that's the point. 1, 2. If we, and what does it say? Locate any relative max and minimum points on the graph. Okay, that works. 1, 2. All right, we're writing it that way just because it said points. If it hadn't said that, then I would tell you that the relative max is 2. Okay, does everybody understand? The function value, the y, that's right. Do we have any others? That's right. Okay, it doesn't have the, we can talk about an absolute max, but relative max says it's the maximum for a certain interval. And so we can clearly define an interval where this is the maximum value within that interval. That's why we say relative max, relative to a particular interval. If it was, well, extreme values describe relative max and min. Okay. Relative min in this case would be what? Okay, -3, -2, since they ask us to describe it as a point, and also, okay, very good, 0, 0. I almost missed that one, and 2, -3. Very good. Okay, so we can see our relative max and min. Questions about that? The y value, right? Okay, and that might not end up being such a big deal here, but when you go on to take calculus, it'll be a huge deal. So I want you to start thinking about that. Okay. All right, even and odd functions. Yeah, a function f is called an even function if for each x in the domain of f, negative x is also in the domain of f, and f of negative x equals f of x. Okay, the graph of an even function is symmetric about the y-axis. Okay, which we talked about symmetry already, right? Okay. A function f is called an odd function if for each x in the domain of f, negative x is also in the domain of f, and f of negative x equals, excuse me, negative f of x. The graph of an even function, of an odd function is symmetric about the origin. Okay, put odd there. It's symmetric about the origin. Okay. All right. So if I ask you to determine whether a function is even or odd, what's our strategy for that? You could do that. That could be a difficult way to do it, but you could do that. Because that would mean you'd have to graph it. Or use something else. What do these two things have in common? Both of them, you do what? Okay, in each case, we plug in negative x, right? And we want to see what that comes out to. If when we plug in negative x, it comes out to be the same thing that we started with, we call that an even function. Okay, if when we plug in negative x, it comes out to be the opposite, negative of what we started with, it's an odd function. If it turns out that it's neither one of those things, then we say it's neither odd nor even. Okay, it doesn't have to be one or the other. It could be neither one. Okay, so let's see if we have that in an example. Okay, determine which of the following functions is even, odd, or neither. Okay, and I really don't need to take this out. We don't need this. They're not really separate tests. It's one test, and we look at the results to see what it comes out to be. Okay, so it will be odd if f of negative x is equal to minus f of x. Okay, so let's take a look. We're going to plug in negative x. We get 2 times negative x cubed minus 6 times negative x. Plug the negative x in. Negative x cubed is what? Alright, and we still got the cube part. So it becomes minus 2x cubed. Is that right? Yes? We still got the cube part. Okay, we had to distribute it. Negative x cubed is the same thing as saying negative 1 cubed times x cubed. Or the cube could go on the outside. So we still have the negative, and we had to still cube the x. Okay, we didn't get rid of that yet. Okay, so we got negative 2x cubed plus what? Okay, plus 6x. Now, the question is, how does this compare to what we started with? Okay, if I factor out a negative, I've got 2x cubed minus 6x, okay, or what? In terms of f of x. Negative f of x, which says this is what? Odd. Okay, questions about that? Does everybody see what we did there? To try to determine if it was odd or even. Okay, we plugged in negative x. We simplified it, and then we tried to compare our simplified version with what we started with. And in comparison, we found that it was equal to negative f of x. Okay, and therefore it was odd. All right. Okay, let's try this next one. Okay, if I plug in negative x, we get 5 times negative x squared minus 3 times negative x. Okay, and so we get what? Plus 3x. Okay, there's nothing we can factor out, so how does this compare to f of x? Is it the same, is it the opposite, or is it neither? It's neither in this case. It's not the same, and it's not the negative of it. Okay, so we say neither odd nor even. Okay, questions about that? How did it become? Well, because in order for it to be even, it had to be exactly the same. Okay, so it's not that. And in order for it to be odd, we would basically have to have minus 5x squared plus 3x. Well, no, negative x times negative x is x squared. Negative times negative is positive. So it was gone away. Okay. This would have yielded odd, but we didn't get that either, so it's neither. Okay. All right, why don't you try to evaluate the last one on your own? Okay, how many people said that it was even? Okay, questions about this? Those negatives, you got to be really careful about them and make sure you're evaluating them correctly. We had a negative out front. That negative that's right here in the front, it's not raised to the 4th power. So he's still going along for the ride. Okay, but then when I put negative x inside of the 4th power, that becomes just x to the 4th. Okay, so that's what I got there. And of course, same thing here, negative x squared. We talked about that a few days ago. When we raise a negative value to an even power, it comes out positive. Okay, and so we got plus 6x squared, and this is exactly what we started with. So equals f of x, therefore it's even. Questions about that? Okay, don't just, say, go away. Which ones? This one out front right here? Okay, that one wasn't raised to a power. Okay, it's a negative, and then we had x to the 4th. That's different from negative x to the 4th. Okay, if that negative had been, if the 4th had been on the negative and the x, then the negative would go away. But it's not. When it's written here, the 4th is just on the x. That's right. Okay, and the negative 1 is not raised to the power. Does that help any? Whether or not it's in parentheses or not makes a difference. And so in this case, the negative is not in the parentheses. It's not raised to the 4th power, so he just stays there. Okay. All right. Okay, let's talk about another concept